Good afternoon all. Am I audible? Hello. Hello. Kavya, am I audible? Kavya?
Yes, ma'am.
Okay.
Yes, ma'am. Audible, ma'am.
Okay. So we are going to start our session. This is week 6 Microelectronics device to circuit session problem solving. I am Arpita Biswas, a PhD scholar from ID Jodhpur in electrical engineering department. This is more details about me, and this class session is every Tuesday 7 to 9 p.m. So let's start the session. This is the question number 1, that in a MOSFET amplifier shown in the figure, find out the relation between the signal output and V1 and the V2. The first option is V1 equal to twice of V2. The second option is V1 equal to minus of twice of V2, and the V1 and third option is V1 equal to V2 by 2, and option D is none of the above. So please try to solve this question. At least try, then I will solve. Take your time, but at least try.
Ma'am, V1 equal to V2 by 2, ma'am.
Can you explain? Just a minute.
When we equating the voltage values, when we equating the current values, V1 by VD, V1 by RD equal to V2 by RD, V2 into RD by 2, ma'am.
Okay, if you calculate V1, at first say what is the value of V1 in that case? What is the value of V1?
IDS into RD, ma'am.
Okay, ID into RD. Then what is the value of V2?
ID into RD by 2, ma'am.
ID into RD by 2.
2.
Now tell me, we can replace this ID RD by V1, then V1 by 2. Now tell me the equation, which equation is satisfying here, which option is satisfying here.
Okay. Option A, ma'am.
Yes, option
V1
A.
equal to
V1 equal to twice of V2. Okay.
twice of V.
Okay.
Okay, ma'am.
So the right option is option A. But good try. Okay. So can we move towards the second question?
Yes, ma'am.
This is the question number 2. Consider the amplifier circuit shown below. The transistor is specified to have VTH equal to 0.4 volt, and Kn, small kn is given 0.4 milliamps per volt square. W by L also given, which is 10, lambda equal to 0, and also let VDD equal to 1.8 voltage. RD is given 17.5 kilo ohm, and VGS is 0.6. Determine the value of the drain current ID. Try. Kn value is given, W by L is given, lambda here 0, it means the channel modulation effect is not here. At least try. Determine the value of the drain current ID. Kavya?
Ma'am,
Yes. Are you trying?
yes, ma'am. Ma'am, from the formula ID equal to Kn into W by L into VGS minus VT.
PTH whole square by 2, right? If it is in
Yeah,
saturation, so then just put the value in this equation.
yeah, yes, ma'am.
All the value are given here. mu1 value, mu1
It's
value is
80 microampere.
okay. Kavya, have you done?
Yes, ma'am. 0.08 milliamps, ma'am.
Yes, the right option is 0.08 milliamps. So let's move towards the next question. This is the question number 3. An NMOS amplifier is to be designed to provide a 0.5 volt peak output signal across a 50 kilo ohm load. Then can be used as a drain resistor if a gain of magnitude 5 is required. Then based on the given data, what will be the value of GM? The first option is 0.1 milliamps per volt. The second option is 0.2 milliamps per volt. The third option is 0.3 milliamps per volt, and the fourth option is 0.4 milliamps per volt. Take your time, but at least try.
0.1 milliamps per volt.
Okay. Kavya, have you tried? Here gain is given, the magnitude of gain AV is given, and based on the given data, what will be the GM? You have to find out the value of GM. Which value? The signal across 50 kilo ohm load. It means RD also given. Now Kavya, tell me what is the value of GM?
Ma'am, 0.1 milli.
Your voice is not clear. 0 point. Hello. You can write in the chat box now, Kavya. Tell me what is the value of AV, how we can write this gain. Can we write mod of AV equal to GMRD? Then AV value is given, RD value is also given. What is the value of GM right now? 5 by 50 milliamps, I think, milliamps per volt. Zero point 0.1, I think, so 0.1 milliamps per volt. Kavya, hello, am I audible?
Yes, ma'am.
Okay. Have you understand what I have done here?
From formula AV.
Yes, the AV formula, which is minus GMRD, and here the gain is given, the magnitude of this gain is given, which is 5. Okay, so now the load resistance also given 50 kilo ohm. Now we have to find out the value of GM. So just put in the, all the value in the formula, and we have calculated the value of GM. Now, can we move toward the next question? Hello.
Yes, ma'am.
Okay. This is the question number 4. Identify the following circuit configuration. The first option is the common gate configuration. The second option is the common drain configuration. The fourth option is the common source configuration. And the last option is the none of the above.
Common drain amplifier.
Okay. Kavya, what is the right answer? Kavya.
Common drain configuration, ma'am.
Yes. Next, move towards the question number 5. The NMOS transistor in source follower circuit shown has GM equal to 5 milliamps per volt and the large R0. Determine the output resistance R output. The first option is 200 ohm, the second option is 400 ohm, the third option is the 100 ohm, and the option D is 600 ohm. The NMOS transistor in source follower circuit shown has given GM value is given, which is 5 milliamps per volt, and here R0 is very large. So determine the output resistance. First tell me what is the value of gain.
Is the output is taken from source side?
If it is source follower, now tell me which circuit or which amplification circuit is known as source follower.
Common drain.
Okay, if it is common drain, then which side you are taking the input and which side you are
Yes,
taking
yes.
the
Outside, then output is taken from source side.
yes.
Then the output impedance will be 1 by GM parallel with RS. So it could be like 1 by 5 milliamps, 200, approximately 200, no? 200
Yes,
ohms.
but yes, it is around 200 ohms.
Yeah, the main formula, am I said correct? That is 1 by GM parallel with RS.
Parallel with R0, right?
Yes, 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 sorry, sorry, R not.
R naught,
Yes, R not is
yes.
very high also you can like that.
Hmm.
Okay.
Kavya, have you done, or I will wait for some time for your calculation.
Yes, ma'am. 200 ohms, ma'am.
Can you explain?
Since it is a source follower, the output, the transconductance formula is GM is parallel to uh, output resistance, ma'am.
So now at first tell me what is the value of gain? What is the value of gain?
Gain is unity. Means voltage gain it's one almost.
Voltage and what is the formula? R0 by R0 which is parallel with 1 by GM,
1/G.
right? And here
Yes.
1 by G.
R0 is very very greater than 1 by GM. So we can write gain almost 1. And our output, I think, yes, our output equal to 1 by GM, and just to get the value of 1 by 5 into 10 to the power minus 3, near about 200 ohm. So can we move towards the second question? Sorry, next question.
Yes, ma'am. Yes, ma'am.
Okay, so this is the question number 6. In which of the following configuration does a MOS transistor work as an amplifier? The first option is the common gate, the second option is the common drain, third option is the common source, and fourth option is the all of the above. So when MOS transistor work as an amplifier?
Common source and common gate.
Okay, and what about the common drain?
Common drain has its voltage gain is unity, so we are generally use it as a buffer. No?
Yes, Kavya, have you?
Ma'am, common source.
Yes, common source can act as an amplifier, and what about the common gate?
Mm,
Think about it, take your time, but then we can move towards the next question, because as Shirji said, common drain we have done in the previous question also, na, this the AV is
common range.
near about 1, so it is acts as a buffer.
Yes.
So for the common
Yes,
source
ma'am.
and common gate, it's acts as amplifier. Okay,
Okay, ma'am.
this is the question number 7. Statement bias point is also sometimes referred to as the DC operating point or quiescent. So is the given statement is true or false? The bias point is also sometimes referred to as the DC operating point.
Yeah, true.
Can you explain little bit?
Like bias point, we are generally find by the use of DC analysis. So before applying any AC signal that we want to amplify, we have to first bias the amplifier in the proper region such that it can amplify and we get the faithful amplification without any kind of clipping or any kind of distorted output. So that first we have to fix the DC current and DC voltages from the IDVGS sorry ID and VDS curve. So where the that IDVDS is cutting the with the characteristics, that is called Q point, or sometimes it's also called DC operating point. So first we have to fix that thing, then we have to apply the AC signal.
Okay. Kavya, what is the right answer?
Yes, ma'am. It's true.
Yes.
I agree with his explanation.
So this is the question number 8. In the circuit shown in the figure, the channel length modulation of all transistor is non-zero, lambda not equal to 0. Also, all transistors operate in saturation and have negligible body effect. The small signal voltage gain V0 by Vn of the circuit is given here, and the first option minus GM1 R01 parallel with R02, which is parallel with the R03. The second option minus GM1 which is R01 and R02 is parallel, and third option is the minus GM1 R01 parallel with 1 by GM2, which is parallel with R02, and whole is parallel with the R03, and the option is option D is the none of the above. So try to solve this question. So what is the right answer?
Is it option B?
No, it is not option B. At
In
first,
option B, it is written as R not 1 and R not 2, right? Or R not 3.
yes, here option B is minus GM1 R0 R not 1 parallel with R0 or R not 2.
Okay, no, then sorry.
At first, convert it the small AC signal circuit, like,
Yes.
then calculate the V output, and then convert and then V output and by V input you have to find out.
I'm just thinking in a direct way, you just please it is correct or not. It's basically M1 is a source, common source amplifier, right? For M1.
Take your time, just do the calculation and tell me the answer, how you have calculated.
Okay.
Take your time, there is no hurry. Kavya, hello.
It's coming option C.
Okay, Kavya, are you trying to solve the question, Kavya? Hello.
Ma'am, I'm not getting, ma'am.
At least try. It takes 2-3 minutes. At least try. Then I will explain. Okay. And in the previous day, you have told me that you are interested in the fabrication field. So next, you're going to do the MTech, right? Hello.
Yes.
So in which field you are interested to work in? Any specific field, like in the circuit, like if you want to do the simulation part, like for circuit you can go for the cadence something, the chip design, like, or the device fabrication. In which field?
No, ma'am. We
Your
can
hello,
you suggest?
your voice is breaking. You are not audible.
And please suggest, ma'am.
No, just tell me your interest in which field you just want to work in.
Fabrication, ma'am.
Like device
Most.
fabrication, right?
Yes, ma'am.
Okay, so what are you doing now? After BTech, you are doing something, or you are just a BTech student?
I'm currently pursuing BTech third year, ma'am.
Okay, okay, okay. For the fabrication, yes, you can come in the sensor part, like the device fabrication. Na? So here also in MTech, this like they are working biosensor, like and also the gas sensor. So particular any field you are interested, or hemp device, like you have heard about this alkan hemp based devices. Do you have this idea about this material, or like something, this hemp or alkan hemp 3,5 material and 2D material, like the MOS2? Have you heard about it, or do you have do you have interest work on this field?
I don't have any idea about that, ma'am.
Okay, like in fabrication based also, now there are some process are there. So if you are interested, in the previous session also I have a little bit discussed about it. So if you have an interest, then you can um, tell me, then I will details, I will explain in details. Actually I'm from this field now, so if you have interest, then I can details explain you, which can help in your future also. Okay, or you can personally mail me. Hello.
You are from IT Delhi.
Sorry, IT Delhi.
Are you from IIT Delhi?
No, I'm not from IT Delhi, I'm from IT Jodhpur.
Oh, okay, okay.
Yes. So Surajit, what is your future aim, like working DRDO, or you want to do the PhD also part time, like some of the students are
Yeah,
doing part time and PhD with their.
yeah. Actually, my plan is to first complete my MTech by from a sponsor MTech actually, because I this year I just joined, so at least we have to stay here. The probation period is there, so at least I have to work here 2 years. After that, they will sponsor. So through sponsored, I actually got this rank today this year with rank 87.
Okay,
So offer from IIT Bombay VLSI solid
okay,
state.
okay.
That was my first priority, but due to some family pressure, I have to join the DRDO. So I think after 2 years, I will switch in that field only. So that's why I am doing this kind of things. Because
Okay,
currently I am in RF in the radar department.
you can directly apply for the PhD also, because some of my friends are doing PhD and they don't have done the MTech. After BTech they are doing PhD. And one of my
Oh,
friend also from DRDO, he's also doing PhD from here, from IT Jodhpur.
okay. That was like sponsored or they have.
No, actually, from I think if you are doing job now, then you can convert it part time. because
Oh,
you are
okay, okay.
getting money from one source, so you can't get MHRD or something else, na?
Exactly.
Yes.
Exactly. Yes.
Like if you are doing like me, if you are doing from MHRD or yes, then you can apply for the PMRF also.
PMR account. Yes. Yes.
Yes. And after 1 year we have applied, like we got the lateral entry in PMRF, so it is also helpful.
Okay. Okay.
But if
That
you are
one I also
doing
see.
a job, then I think only one option, the part-time conversion.
Ah, good. Correct. I means doing MTech is for beneficial only for job or I can do for directly PhD. Which one should be better?
Like if you want to go for the teaching profession, then I think PhD is the better option. But MTech is also, you can got if you are doing from the IIT, then you will definitely get the good job after MTech also. And if you are doing MTech from IIT, then definitely you will got selected for abroad. Like okay,
Okay.
some of my junior also, they have selected PhD in NTU Singapore from IIT Jodhpur.
Okay. Okay.
So it will little bit helpful, but their motive is for, go for the professional like teaching line, na. So it is
Exactly.
okay for them, because fabrication field here mm, nowadays it is just developing stage, device
Exactly.
fabrication. But you
Yes.
will got more chances if you are doing something digital VLSI or like analogs domain.
Like my main interest in the mixed signal designing part is there, na, in
Mm-hmm.
Below. Like where in that case we have to means studied all the things like embedded digital analog means we have to study all the things and we have to implement, na, or it's a defined kind of things.
Mixed signal means you are just telling about this analog circuit, like you have already seen in the cell lecture, na? Like there in Cadence or something else software, they have designed the layout something.
Yes, yes,
You have already seen this type of things is the part of analog. I think analog circuit, like the chip design like that, but the device fabrication
exactly.
is the totally different thing. I have in the previous session, if you have seen the video, then we can go through each of the stage, because we prepared the device, like there is a silicon wafer, then how we prepare, how we clean the wafer, because we need the clean room for when we go for the MEMS design device now, then we need, yes, then we need the clean room. And what happened in that case, the particle size, dust particle size is also is a big things for the fabrication field. So at first the cleaning, some cleaning process we have gone through, then after that some of the deposition technique, as we have discussed in the earlier session. Like if you want to grow some oxide, then the oxidation, different type of oxidation process is there. Then there is different type of deposition type, like CVD, chemical vapor deposition, the physical vapor deposition techniques we have gone through. Then
Okay.
this is the totally device fabrication, like we now I'm working on the biosensor 2D
Oh,
material based, so we have to using the CVD, we have to grow this 2D material. Then after that we prepare the contact something, so so in that case we have used the PVD technique, physical vapor deposition, like thermal evaporation system, E-beam sputtering, like that. Okay, then we have done the electrical, some material characterization we have to do if we are growing or synthesis some material. In that case also you can if you are interested in this field, you can go through some of the material characterization, like the Raman, FESEM or STEM, the STEM,
okay.
the transmission electron microscopy, like that. And also then we go through some of the electrical characterization, and there are some different type of machines are there, so we can optimize your device, it is working, it is sensing something or not. Mostly we are
Okay.
working on the
Means
sensor.
it's only based on the fabrication part only, na? Means core fabrication.
Yes, this is the pure core fabrication field.
And what is the current means current situation and the scope of this thing in the India?
Actually, the device fabrication is the developing stage. I think if you like if you done here from
Like
the
we are also some procure some of the PCBs and all. We are giving the orders like Micropack, electrolytes. Some of the Hyderabad's Bangalore's company. They also give us the RF PCB and both DC PCB. So for that RF PCB we are using the Rogers substrate. Okay.
okay.
So they also supplied, right? But some of the PCBs that the way you are talking now, some of the cleaning part is there. Some of PCB I also noticed some kind of not sharp cutting in the edge terminals. So some of the things I have also noticed. I also discussed with my senior scientists. So they told ki right now maybe some issue is there during their fabrication, or maybe the whatever, maybe the internal
This
stages.
fabrication is also the different type of fabrication which I am talking now. This is also another type of, like you can search on the 2D material based biosensor or the MEMS fabrication, like which we have done using the photolithography. This is the different type of, and the PCB fabrication, this is the another type of device
Okay,
fabrication. Okay.
that two are two different things, no?
Yes, because in the device now, like now I'm discussing about some of the cleaning process. Like if there is only the silicon wafer and there is some organic or inorganic particles are there, then which type of cleaning process you are going to do? Some standard cleaning process, you can have you heard about the Piranha cleaning process?
No, I don't know about
So
this.
there is a Piranha cleaning process, RCA1, RCA2, the standard cleaning. This is called the standard cleaning process. Okay, so like there are some chemicals are used in Piranha also, hydrogen peroxide and the H2SO4, and the ratio is H2SO4 is I think 3:1. They have mixed a mix and then they clean the wafer. So it is a strong cleaning process. So they can use it for the,
Means it is all the thing that you are now currently doing. That is for the only the make this wafer good, or and that wafer is
actually
used and in the ICs and all.
when you are working in the micron size na, a dust particle also has a micron size dimension. So if your
Yes, yes.
like there is a two contact, if in between the two contacts is the micron size and your dust particle is also micron size, you are not cleaning, what happen in that case? You are going the proper device? No na. This
Yes,
is
yes, correct.
happening. That's why we have to clean properly, so there are less amount of the dust particle or the contamination happen. That's why we are going through some of this cleaning process.
Okay. Then after that, those wafers are used for what?
Yes,
Like for
for
designing
the
for what?
later purpose we have used, like if you are go for the photolithography, then what we have done in the previous case I have already discussed this, how you do the like if you want to fabricate a pressure sensor. Have you heard
Okay.
about the pressure sensor?
Yes, yes, pressure sensor.
Do you have any idea how is the pressure sensor work?
No, I am not what is it.
Like
I'm not in this.
this type of diaphragm there, okay, and this is total the silicon wafer and this type of diaphragm is there. So when there is a pressure is given na, so this wafer is bent, and this wafer is bent, so the electrical property of this like of this material is changes, and we have just find out how the resistance or the electrical property of that material it changes. So we can tell that the yes, this is the because of the pressure it is changing. So now we can tell it is a pressure sensor. So how we like prepare this type of bending shape? So it is gone through some of the steps like photolithography, etching, or some cleaning process. Okay, so this
Okay.
type of thing, this is the pure device fabrication process.
Okay. That is also then good. Actually.
Yes, sorry.
I'm saying that is also a good thing then for
Yes,
studying all
all
of
the
these things.
sensor you can fabricate, and all type of like some here if you are giving some input as a pressure, this is called the pressure sensor. If you are giving some of the biomolecules and it is changing the electrical property or some of the material property, then you can say it is a biosensor because from the biomolecules it is changing. or if you are giving some of the gases, that's why the electrical property is changing. So you can tell
Okay.
it is a gas sensor. Like this type of sensor we can fabricate here. The PCB is totally different things from it, but
Is
this is the
different.
device fabrication process we prepared, like just like a MOSFET. Okay, that's
Yes.
this type of sensor. There is like a MOS using the this like the 3,5 material, the 2DG. You have already, I think, gone through, right? 2DG.
2DG. No, no, I don't know. What is
Okay,
this?
then most probably in MTech you can go through it. What is 2DG layer? When you are
Okay.
using the 3,5 material, what happen in that case when it is interact with the molecules? Then what happen in that case? So this is the totally device fabrication process, and it is little bit different from this. But yes, some of the part you can find here that the some of the like oxidation process, like deposition process, they are the same.
Okay, okay. Means that's actually now currently the state is actually upgrading, na?
Yes, it
This
is
field.
in developing stage, I think. But
Okay.
on some of the labs they are working like CSIR CD. If you had heard about it,
Yes,
CSIR
yes,
CD,
actually, yes.
they are working on the proper
Okay. Actually, I'm from Kolkata, so here is there is no such like
Yes,
not
I
such kind of
think in IT Kharagpur, I think the device fabrication, but we have like in the sorry, not gas sensor, in electrochemistry they are doing some of the uh, mm, sensor portion, I think electrochemistry, because I have also given the interview. So in that
okay,
time they are asking mostly they are asking about this MOSFET basics, like, and also their
okay,
the
okay.
electrochemistry, most of the question from their side, they are the electrochemistry.
Oh no, our DRDO lab is also there in the Kolkata. That is CMSDS lab. Okay, that is
Okay.
for means VLSI domain part. The means only the semiconductor based lab is that only.
Hmm.
But they are actually doing the designing the diode, actually impact diode, pin diode. Okay, at very high frequency diode.
Okay.
So, but most of the things they are doing outside, and at the last stage like simulation optimization, that thing only their scientists or whatever those their staffs are there, they are actually doing,
Okay,
and
so
only cutting and edging
mainly
they are.
mainly they are doing the like the fabrication part of the high frequency diode, like, or
Yes,
only
yes,
they are
fabrication part and
simulating.
only mainly simulating part is there. Okay, mainly simulating and optimization, because those diodes are giving very much output. Because also we have to tie up with other institute also, because we are not able to like for example impact diode. Okay, so impact diode they are designing for generating your transceiver system. But for the transistor system, there should be a proper oscillator also there. So that oscillator you have procure, and you put that diode in the oscillator. If it is properly designed, then for example, 94 gigahertz you want to generate for the radar purpose, radar transmitting section. So for if that 94 gigahertz is properly coming, then we decide if that diode is properly designed. If it is not coming, some oscillation will be there. So in that case, we have to again
So
recheck
what is
and
the application? Mainly the radar, like.
yes, that application is like most of the high cavity output is there, na, like 20 watt, 8 watt. This is a very huge power in the RF domain actually. So if you want to design a very high transmitter, high power transmitter, or maybe in the uh, antenna device from ground base to a satellite communication. So for that thing, you need a very high power communication system. For those
Okay.
diodes are using that thing only, and lots of other things also there, but that lab is dedicatedly for only this kind of semiconductor device. Only this lab is there in the Kolkata. Other
Okay.
labs are doing for different things, but you are telling that thing, so that's why I recall ki one lab is there, but they are also not doing all the thing by their own. Some of the companies also tie up with that lab actually.
Yes. And also in the
But I am
institute level, it
most.
is also developing stage,
Yes,
I
yes,
think.
definitely, definitely. In the Kolkata also there one is institute is there is Summit. Summit also tie up with IIT Jodhpur, I think.
Okay.
Okay, so and IIT Jodhpur also because our director in RCA lab. His son is actually doing BTech from IIT Jodhpur.
Okay.
So his father is in scientist G post currently. So he told कि IIT Jodhpur is academically is very good college. And some of the Samir Institute is tie up with IIT Jodhpur. Now currently they are doing I think 6G project because India's newly project has come. So for 6G project only Samir, IIT Madras and IIT Patna these three are involving I think for developing the devices and for simulating the path. So IIT Madras is chosen because of their good accommodation of research for research or orientation. And IIT Patna I think also did some very high frequency devices like two or three couplers and mixers also they have designs. So for that thing they have give the responsibility. And Samir is very famous for the especially for the W band like 75 to 110 gigahertz na. So
So
that is the
now you
very
are working on which like only the diode.
no, currently I am actually in the circuit and system division. Here we have to design the PCB. Means I mostly I combine with both RF and analog domain. But I want to currently I am also doing the MMIC part also. So these three I just parallelly doing like circuit and system division and the radars part and the MMIC designing. So in future I want to move only for the analog domain actually. That's
Okay.
why I just
And it is totally like almost different from the analog domain.
yeah definitely.
Yes,
So that's why I
this is
giving
properly
some
just device fabrication. You have to go through some of this process, and you just have to fabricate the device. Then
yeah
later
exactly
part you can convert it also in the circuit. How you can
exactly.
convert your device into the circuit.
Yes. I also don't know much about idea about this fabrication part. I thought initially when I get time I'll just study about those things, but not get time. But I have to study I think this part, all of this part.
In the M10 also we can little bit study about it if because I think if we can combine this fabrication and the analog domain, then it will be more beneficial.
Yes. So currently you are doing PhD, no?
Yes, PhD. I have just completed 2 year.
Oh, and MTech you did from where?
Triple IT Jabalpur, and also in device fabrication. Like I have done in the simulation portion, in the device simulation portion. Like here we are just practically just fabricate the devices, and there I'm just simulating how to fabricate. All the things are like theoretical portion we have done,
Okay.
and here
So
practically.
you have to research some new things and whatever the outcomes is there, you have to means based on that you have to write some how many papers you have to publish during your program.
Just
It is
recently.
any mandatory.
Yes, in PhD, I think 2 or 3 papers are mandatory. We have to complete it.
Okay, and that should be a standardized like
Yes,
IEEE standardized.
yes, it should be standardized, not.
Okay, okay, got it. So, is there any way to connect with you like any other way or mail
You can
or
directly mail me.
okay, well, just tell me
Uh,
or you can type in the chat box.
biswas.5 @iitj.ac.in.
Wait,
Here I
Vishwas
have
dot
also joined from this ID biswas.5 @iitj.ac.in.
I J.
Yes, IITJ, J for
Uh,
Jodhpur,
yes,
.ac.in. So you have completed your BTech in 2000 which session?
2021.
Okay, 2021 you have completed, and after that
Yes,
2 year you were preparing for the gate.
yes. 22 years. Last year also, and last year my rank was 821.
Hmm.
And then again I prepared. Means the first attempt 22, and the second attempt I did 87, like 23.
Okay,
That I joined here.
and it is self study or you have taken some from somewhere?
Yeah, self-study.
Yes.
Yeah, it is self-study totally. I follow the standards books like NPTEL lectures. So I follow.
Okay, okay. Okay, so let's start the session. We have to complete it also.
Yes, yes, correct.
Okay.
I think someone is left. So.
Yes, only you are here. Okay.
Okay, okay. So one second. IIT J, that is caps or what? Small, na?
Small, small.
Okay, okay.
So let us start this question. What happened? Okay, let's draw this figure. Source. So I'm solving this question. Please see it is matching with your answer or not.
I actually did like individual resistance, okay, for active load,
Okay.
and then make it parallel.
Okay. Any of the process you can follow.
Yes, yes.
This is GM VGS3, and this is R03, which drain is connected with. This is the drain. It is connected with the second one, source. This is the source, negative, and this is the gate. PGS2. This is GM VGS2, GM2, GM3, and this is R02, and from here it is grounded. And this is the source portion. Yes, this is all right. And from there also the drain portion. Here is the source, and this is gate. PGS1, this is the input PI, and this is resistance R01. This is GM1 VGS1. Okay, now calculate the V output from here. V output is minus GM1 into VGS1, which is R01. R01 is parallel with the R03, and which is parallel with this one. So we are seeing from the source. So then it is parallel with the 1 by gm2, which is parallel with the r02. Now calculate the V input. V input is VGS1. Then what is the value of AV or gain, or V output by V input? Minus GM1, G1, VGS1 cancel out. Then we can write R01, which is parallel with, we can write 1 by GM2, it is parallel with R02, overall parallel with the R03. So now it is matched with your answer.
Yeah, just matched.
Okay. So move towards the next question. This is the question number 9. The parameter of the circuit shown in the below are VDD equal to 5 volt, R1 equal to 520 kilo ohm, R2 equal to 320 kilo ohm, RD equal to 10 kilo ohm, and RSI equal to 0. Assuming the transistor parameters of VTH in VTH is 0.8 volt, Kn is given 0.20 millivolt per volt square, and lambda is 0. Determine the small signal parameters Gm. The first option is 2 to 2.5 milliampere per volt. The second option is the 0.4 to 0.5 milliamps per volt. Third option is 0.8 to 0.9 milliamps per volt, and the last option is the none of the above. So please try to find out the answer. VGD is given and different resistance value are given. RSI also is given, which is 0. Kn, it is capital Kn, so we can directly take in the half of mu and COSW by L value is given here directly. Lambda value is given, so there is no channel length modulation. Just you have to find out the GM.
It is coming 0.442.
Yes. Can you explain?
Like first I find the BGS for finding the GM.
What is the
So
value of VGS?
yeah, VGS I found like by division R1 R2 in a series. So by division I got the VGS R2 by R1 plus R2.
Yes, the voltage divider rule, R2 by
Yes.
R1 plus R2. Then what is the value of VGS?
VGS is coming. Where I wrote it.
320 by 520
It's coming. I
plus
think
320 into 5 volt,
1.905.
1.905 volt. Then tell me what is the value of ID?
Let me check once.
Here Kn is capital Kn is given. Just put this value directly. And what is the value of
Yes.
VGS? 1.905 minus VTH 0.8 whole square.
Square. Yes.
This value is 0.244 milliamps.
Yes.
Now how to calculate the GM? What is the equation?
GM we can find by using ID.
Yes.
By using ID, it is 2 into Kn dash into omega by L into ID.
So we can write
So,
like this. Okay. What is the value of Kn here? 0.20 and value of 0.244. So this value is 0.442 milliamps per voltage. So this is the question number 10. For the PMOS transistor in the circuit shown Kn equal to 8 microampere per volt square and W by L is given, which is 25, VTP is 1 volt and I equal to 100 microamps. For what value of R is VSD equal to VSG? For which value of R VSD equal to VSG?
Is that kn value include that 1 by 2 factor?
Just don't go in the
No.
difficult process. Just see, if you are giving some value of the R, then if the VSD or VSG will be same, VSG, this voltage, or and this
Yes.
voltage, when it will be same.
Like if it drain and gate are shorted.
So it means there is no resistance is present, na?
In between drain
Their,
and gate.
like you can
Yes,
see
yes, yes,
from
yes, correct.
their portion it is shorted, only the resistance value is here and it is
Yeah,
also here, it is connected. So if the
yes,
R value is 0, so in that case what happened, the VSD equal to VSG. Okay,
yes.
so R value is 0. So this is the question number 11. So now we are going for some of the MCQ question. The common source stage of a CMOS amplifier provides. The first option is the moderate voltage gain, low input impedance and the moderate output impedance. The second option is moderate voltage gain, high input impedance and high output impedance. Third option is the moderate voltage gain, low input impedance and low output impedance. And the fourth option is the moderate voltage gain, high input impedance and moderate output impedance.
It says moderate voltage gain. Input impedance common source is input impedance of a common source amplifier is
Just
high. High.
if it is a like MOSFET common source,
Yes.
okay, it is grounded and so input is going from the uh, gate side
Gate
and
side.
here is
Yes.
also the capacitance, like AMO is a structure, oxide is present, so
Yes.
input
Yes.
impedance is infinity, like almost
Yeah.
infinity. So
It's
the
very
input
high.
impedance will be high, input
Yes.
impedance high.
And
And what about
output
the
impedance.
output impedance?
Output we are taking from drain side, so it will be unknown. It's
Yes,
also high quite.
it is high, but what happen in that case, like it is the resistance which is present, like
Yeah,
this
I
is
can
in the
check the load
parallel
rate.
condition.
Yes,
Yes,
yes, correct.
so it is
Yes,
also in the kilo ohm, it is also kilo ohm, but
yeah,
you are taking the parallel, like something.
yes.
Okay,
It will be less
like
than
if it
the
is
value.
taking the parallel condition R1 R2 something or RL RD, so in that case you can tell it is a moderate high.
Moderate, correct. Yeah.
Okay,
Not that much high, but correct. Yeah.
yes, because it will also come in the kilo ohm, but not that much because it is in
Yes,
parallel condition. So moderate
yes.
output impedance, high input and moderate voltage gain.
But intrinsic, if we take, then that is coming as unknown, na? If they ask intrinsic output impedance, that is only unknown, right?
Yes, intrinsic you are taking from this side, na? This side is are not like here, na?
Yes, means when we are not connecting anything like RD or RL.
Okay, in that case also you can take. I'm just think from this direction that if there is a some resistance is there, so it will be in the parallel
Yeah, yeah,
position. So it is in the kilo ohm. So in parallel it will also in the kilo ohm, but the
yeah.
value is moderate, like somehow the below of this volt resistance.
Yes,
Okay, so the right option is 4.
yes.
So this is the second, this is the question number 12. An amplifier is designed using a fixed bias configuration. What is its input impedance? It is also for the common source, like. So what happened in that case? Resistance or impedance is very high in input side. If there is an any other like this.
Then what for it is fixed bias means then in that case the resistance will come
Yes.
grounded. Yes, then it is RG only.
Then yeah, and also the Z input infinity and it is Rg. So in one infinity and this Rg will parallel. So the value
Yes,
will be only the Rg.
yeah, almost RG.
The 13 number question is the self bias configuration contain Rd value is given, R is given, Rg is also given and Gm is given. So determine the AV. At first tell me the equation to how to calculate the gain when Rs is given.
When RS is given, it's a common source, right?
Hmm. So it is a degenerative, right?
Self bias configuration. So the gain will be less, means minus GMRD by 1 plus GMRS.
Yes.
That factor the gain will reduce.
So AV
So
equal to GMRD minus of GMRD by 1 plus what?
1 plus GMRS.
Now tell me what is the value of it.
2.5.
GM value is 1.5 into RD value
It is
3.3 1
minus 2
plus GM
and minus 1.98.
1.5 into RS value 1. What is the value of it?
Minus 1.98.
Okay, so it is almost minus 2. So the right answer is option A. This is the question number 14. What is the reason for connecting a capacitor in a parallel with RS? It is for also the common source. It is common source. Okay. So first option it blocks the noise. Second option for AC signal it acts a short circuit resulting in grounding the source terminal. The third option is blocks the noise for AC signal. It acts a short circuit resulting in grounding source terminal. Or option D is to increase the impedance. Ramakant, what is the right answer? Please unmute yourself.
C, ma'am.
Okay. So the right option is the option C. It blocks the noise for AC and for AC signal it acts a short circuit resulting in grounding source terminal. The question number 15. A sinusoidal signal has 1.5 at t equal to 2 second. If the signal is given to common source amplifier with AV equal to 5, what will be its output at t equal to 2 second? First option is 7.5, second minus 7 point, then 0 or 15.
Minus 7.5.
Okay. Ramakant, what is the right answer?
Madam, minus 7.5.
Can you explain how you have calculated? Yes. How you have calculated? AV is given here. Okay, mod of AV. And AV equal to, how you can write? V output by V input. Okay. And here the value at t equal to 2 seconds, the value is given which is 1.5. So the value of V output 5 into V input 1.5, so value 7.5. But here it is the magnitude value of the AV is given, it is the 180-degree phase shift, sorry, the V output here minus 7.5 volt. So the right option is option B. This is the question number 16. For a self bias amplifier, R is equal to RD, the output will be same as input. So say our second option is the same as input but phase reversed, or option C is 0, or option D infinite. So what is the right answer?
Option B.
Okay. Ramakant, what is the right answer?
Madam, I don't know, madam.
Shurjit, can you little bit explain?
For common source amplifier, if RS with RS, then we can approximate the gain as minus RD upon RS. If GMRS is much greater than 1, in that case we can take the gain is minus RD upon RS. So in that case, if RD equal to RS, so gain will be 1. Initiate is 1, but phase change will be there, 180 degree out of
Okay.
phase.
Okay. Then see here, if it is a common source and the RS also is given, okay, then in that case we can write AV equal to minus GM RD by 1 plus GM RS. Just put the value here, AV equal to, write down 1 by GM into RD. So like GMRD by 1 plus GMRD, it is almost 1. So we can write in the case of AV, which is V output by V input, it is minus 1. So V output is minus of V input. So the second option is the correct, same as input but phase reversed. Okay. Ramakant, is it clear?
Yes, madam.
Okay. This is the question number 17. Which of the following statement is true about the phase FET common source amplifier compared to BJT amplifier? The first option is it has high input impedance. The second
Yeah,
option
madam.
is
Yeah.
it has low input impedance. The third option is no input voltage is needed, and the fourth option is input voltage is needed.
High input impedance, A option.
Yes. So the question number 18 is output impedance of common drain amplifier is, the first option is RS plus RD, option B is RS, option C is RS parallel with RD, option D is RS parallel with 1 by GM. Output impedance of common drain amplifier.
I think it will be RS plus 1 by GM, no? If RS is there, up to source terminal,
Like
it will be 1 by GM.
see, here the RS is present and this fate also given the resistance value 1 by GM.
1 by GM, yes.
So if you are taking in from that side and here it is grounded, you can recheck it, because in from this direction this GM is parallel with this RS. You can recheck it. So the right option is that one. You can recheck it. This RS is parallel with this 1 by GM or plus with this 1 by GM. when you're
Yes,
converting in the
RS.
AC signal, na? How you can write it? Ramakant?
Madam?
Yes. What is? Have you understand it? Where
Yes, yes,
it
madam.
is? This is
RS.
RS plus or RS parallel with the 1 by GM.
Madam, it's RS parallel with 1 by GM, madam.
Okay. You can also recheck it. It is plus or parallel. Okay. It was converted the AC signal circuit and then calculate the output impedance. This is the question number 19. So a common drain amplifier is designed using a fixed bias configuration. What is its input impedance? RD plus small rd, or option B is RG, option C is RD parallel with RD, or option D 0.
RG only, ma'am.
Okay. Ramakant, what is the right answer? Common drain
I think
amplifier.
RD plus RD.
Common drain amplifier. See the circuit. Like here it is grounded. Common drain.
Yes,
Okay.
yes,
Your input is going from the gate and output you are calculating in the source side.
source.
Okay. And common drain amplifier design using what is the input impedance, and input impedance here the MOS structure is
RG.
here na.
Yes, ma'am. RG.
So the input impedance in like tends to infinite, and also if it is self biased there a RG is also present. Okay, then this Z value which is infinite, which is parallel with this RG value,
Then RG equal to RG.
then it is equal to RG. This is the question number 20. Which of the following is true about the common drain amplifier? It has low input impedance, it has high output impedance, C infinite gain, D output will be the same as the input.
D, madam.
Both same as.
Yes, actually
Output
common drain is
impedance.
acts as a buffer circuit also. So common drain
Yes, yes,
amplifier, you can output will be the same as the input.
yes, yes.
This is the question number 21. A sinusoidal signal has 1.5 volt at t equal to 2 second. If this signal is given to common drain amplifier, what will be its output at t equal to 2 second?
One point five volt, right?
Yes.
1.5 volt.
1.5 same as same.
Okay. So the right option is 1.5 volt.
D.
Question number 22. A sine signal with a period of 2 seconds has a peak of 2 volt at 0.5 second, and at 1.5 it was minus 2. If this signal is applied to common drain configure amplifier, what will be its output at t equal to 1 second? First 2, second option is minus 2, third is 0,
And
and
it's
D is
C,
0.
madam. C.
1.
0 volt.
C 0 volts.
Yes. This is the question number 23. Which of the following is the other?
Source follower. A, madam.
Yes, the source follower. This is the question number 24. If GM is given 0.5 millisecond and RS is given 2 kilo ohm, determine the R0 for source follower circuit.
2K parallel with 2K. 1K, madam.
Yes. And this is the last question. A common gain amplifier has high input resistance and high output resistance, low input resistance and high output resistance. The third option is low input resistance and low output resistance. And the fourth option is the high input resistance and low output resistance.
Option second option.
Fourth,
Low input impedance and high output.
common gate.
Yes.
high.
Like the gate is common here,
Looking from source side, impedance is low.
and here is your drain, like some resistance is there. And if you are seeing from the source side, here it is the, if it is connected with the gate, now in that case the input resistance is infinite. But if you are taking from the source side, then what will be the impedance?
1 by GM.
Yes, and its value definitely in some finite value.
Yeah.
So low input resistance.
Depend, low output resistance also.
Yes, and also you are getting the low,
High output
sorry,
impedance.
high output. Yes, the option 2 is the right answer. The high output resistance, it is low. Actually, today up to this, I have select the some of the question. So Ravi, you can leave if you want, and Ramakant, if you want to see the previous question, so we can discuss right now.
But I would like to see the previous questions, madam.
Yes, which we
Just
have already covered. So, do you want, or I will end the session here? Can you go through some of the previous question? Like we have.
sure. Okay.
Okay.
Sure, madam.
Then I have a separate meeting also, then I'll just leaving, okay?
Sorry, what you are
I have
saying?
some my meeting also, okay, from 9 p.m.
Oh,
So I just leaving, okay?
okay. You can leave.
Okay, okay, thank you.
Yeah.
Madam, this will be available, na, madam, video. This video recording video.
Yes, I'm going to upload it after the session. Okay.
Okay, madam. Okay, madam. Okay, madam.
So we can
Thank you,
continue,
madam.
or you can see from the video.
Okay, madam. I will see in the video, madam.
Okay. Okay.
Thank you, madam.
Okay. I can do. Thank you.